Now that's the jankiest space rock I've ever CG'd. Welcome to the Macke Makerspace. Hi, I'm Brother Bob Macke, the curator of meteorites at the Vatican Observatory, and I recently spent a few more months back in Tucson, Arizona to work on the Pycnometer for the OSIRIS-REx space mission. Now, I'm back in Castel Gandolfo, Italy, but the months in Tucson were very eventful. And I've already made 2 videos about the Pycnometer for which I include a link below. Check those out if you haven't already seen them. And just as a recap, the mission visited the asteroid Bennu to retrieve some specimens from the surface. And as we speak, it is heading back to the Earth with the precious cargo so that we can study these specimens in the laboratory. Now, part of the research plan involves measuring the density and the porosity of these specimens with ideal gas pycnometry, for which I am building a custom device that will be installed in a clean room glove box at NASA Johnson Space Center. And since the last video, we took the Pycnometer prototype to NASA for an exercise out there, and to get feedback from the folks out there to improve the design. And I'll say more about that later in this video. But first, I had mentioned last time that I would show you a little bit about what our student worker, Derek Lee, has been working on. So let's hear it straight from him.
Hi guys, my name is Derek Lee, and I'm currently a student at the University of Arizona studying systems engineering with industrial minor. Now I'm partnered up here with Dr. Macke to work on this Pycnometer electronics box. Currently it functions as a way to be able to deliver power to the entire system, to be able to control the individual valves of the Pycnometer. Yeah, so right now, what we have on the Pycnometer is 2 power supplies. One's a 24 volt power supply and a 12 volt power supply. One delivers power to the to this power distribution panel, and the other one provides power to the switches for the different valves. And right here are our computer interface modules. This one right here, if you can see, this National Instruments board, which is more of like a compute module that relays, what's it called, LabVIEW code to be able to program the entire system to do what we want it to do. This one right here controls the, interfaces between the computer and the Pycnometer electronics box to be able to relay information onto this board to ensure that we want like an on or off type of state for the valves. So yeah, right here we have all the wires going in from the actual the Pycnometer box. Every 2 wires, as you can see, we have 2 of the same 2 of the same colors, and each 2 of the same color is going to be controlling one different valve, and it all gets looped onto this board.
At the beginning of March, I packed up the Pycnometer to take it to NASA Johnson Space Center in Houston. And while there, I had a chance to check out the clean room laboratory where the Bennu specimens will be stored and studied, and where the glove boxes will be installed. The glove boxes themselves are still under construction, but there were mock-ups set up in a different building for the exercises we were doing. And by exercises, I am referring to SA-SOPIE3, short for Sample Analysis Science Operational Proficiency Integrated Exercise. Try saying that 5 times fast. Maybe that's why we just call it SOPIE. And it's basically a dress rehearsal for opening up the capsule and doing the initial assessment and analysis of the specimens that are inside. Now, somebody prepared a secret sauce of specimens, a mix of meteorites and earth rocks and simulant, and this time dust, lots and lots of dust. And our job is to examine it and to find out what's in there. We're trying to answer some basic questions like, are there more than one type of rock inside, or is everything the same kind of rock? From what we saw on the surface of the asteroid Bennu, we expect to find two and maybe more. And this initial assessment includes multispectral imaging and then selecting a few stones of interest that we think represent different lithologies. And then we'll do some basic studies on these stones, including structured light scanning for bulk density and ideal gas pycnometry for grain density and porosity. And the results of this initial study will help inform the selection of specimens for more detailed science to be done in laboratories around the world. Now, this was the third SA-SOPIE exercise, but the first one with the pycnometer actually present. And it gave the curation team an opportunity to examine the device and to give some useful feedback.
On the, like a circular Teflon piece at the very top of that it pushed on.
Yeah, in my
Something
original
like that.
design, I had that. I sort of got talked out of it because the Teflon would wear, and a lot of this is dependent upon the.
We had to set up the pycnometer in a space with a proper gas feed, and the only available spot was in the Antarctic Meteorite Lab, which is also a clean room. It's not at the same level of cleanliness as the OSIRIS-REx lab, so we only had to wear smocks rather than full bunny suits.
And we're inside the Antarctic Meteorite Processing Lab, right? At Johnson Space Center in Houston, Texas. Brother Bob is working hard here. Bob might cut my voice out here, but if you use it. But I'm Professor Harold Connolly from Rowan University, a mission sample scientist for OSIRIS-REx. So you're mounting that box to the actual holder, so that would be on the outside of the glove box when it's finally assembled with the glove box.
Exactly.
Okay, got it. With the pycnometer, which is over there, would be in the glove box. Yeah, sure.
We did send a big, so that's why it's a little better. We did send one big shipment to them a couple months ago, and so we're preparing another one.
And during the exercise, the curation team handled the specimens in the sample chamber while I operated the software. And this is how we're actually going to be operating the machine in the real scenario. And the team was an absolute pleasure to work with. I really enjoyed the process.
Yeah, so now we remove the cup. Yeah, and you might want to put your hand on it. Yeah, great. Good.
Protect the sample like that. And then pull this out.
Yeah, and pull the specimen out. All right, let's see if it fits. Oh, it fits.
Yep.
Okay. Now, one thing to be aware of, see how the foil is kind of leaning over the edge? We want to make sure that, because this surface here has to, the other surface has to press against it, so we don't want any foil leaning over the edge here. So just kind of fold it in, just so that when we compress the lid, it's not going to go on to.
Mm-hmm.
Yeah. We don't want it to fold out. Is the thing.
Okay. It's upside down.
All right. Okay, Andy. If yeah. Were you able to get something good?
So how did the pycnometer perform? I think it did great. We were able to distinguish a few distinct types of rocks among the mix, and even got some hints as to what kind of specimens they were from their density and porosity. And now that the exercise is done, we have some great feedback for building the final version of the Pycnometer. And I threw together a little CG animation to show its assembly and what it's going to look like. Enjoy! Most of my videos are a one-man operation, but this one was a real team effort. I have to thank many people who were involved in this process, both on screen and off. And I'll provide a full list in the next shot, but at this time I would like to highlight Harold Connolly, the sample analysis team lead, who provided some of the footage. And much of this video was also filmed on location at NASA Johnson Space Center and would not have been possible without their cooperation. This project is supported by the OSIRIS-REx mission, but my channel is not supported financially either by OSIRIS-REx or by the Vatican Observatory. And the purpose of the Vatican Observatory is to be a sign to the world of the compatibility of faith and science, and it could use your support. If you would like to support the work of the Vatican Observatory, or even just to learn a little bit more about it, there is a link in the description below. Thank you.
And we're inside the Antarctic Meteorite Processing Lab, right? At Johnson Space Center in Houston, Texas. Brother Bob is working hard here.
Hardly worth it.